Welcome to One Chemistry. In this video, we are going to see what is Zintl salts. We will see basics, problems, and more importantly, step-by-step procedure to identify the structure. Stay tuned. What is inside this video? First, we will see library of reference. It help you to learn. It will help you to solve the problems by yourself. Further, we see basics including formula, structure prediction, Zintl salts examples, and common mistakes. More importantly, we are going to solve 20 example detailed way. Here I given quick reference for Zintl salts, basic structure and respective compounds. The common structures are Closo, Nido, Arachno and Clado. I organize the library based on the four structures. Make use of it, solve the problem by yourself and know the possibility of the compound. We are going to find the structure of the compound through the weights rule. So you should know what is weights rule, why the weights rule. Weights rule is an important concept because it helps you to find the structure of the Zintl salts by simple formula. We are not using any structure or simulation or even any instruments. So it is very important and handy. Mostly we are using it for boranes, heteroboranes and Zintl salts. Here many borane derivatives are possible. Simple borane, heteroboranes, Zintl salts, borane with charges, borane as salts. Many things are possible, but our focus is Zintl salts, basically metal cluster. So we are going to use weights rule for Zintl salts. Basically we are going to use weights rule for Zintl salts. First, you should know what is Zintl salts. Zintl salt is a metal cluster formed only by metals without any ions, simply by metals. Here is shown Ru8 minus. It is an anion from ruthenium. It forms cubane-like structure. You can see structure is only formed from ruthenium. 8 ruthenium, 8 corners. So Zintl salts are basically a metal cluster, form unique structure. Before getting into the detail, you should know the basic shapes. Then only you can understand weight types. Shapes normally dictated by the vertices. 4 vertices mean tetrahedron, 5 mean trigonal pyramidal, 6 mean octahedron, 7 mean pentagonal bipyramidal, 8 mean dodecahedron, 9 mean tricapped trigonal prism, 10 mean bicapped square prism, 11 mean octadecahedron, 12 mean icosahedron. These are all basic types. There can be a variation or modification. All are possible. You should know these basic types. Then only you can understand the weights rule. Normally, we will study Closo, Nido and Arachno. What it really mean laws of atoms. Close mean normally closed structure. There is no atom missing. Nido mean only one vertex missing or one atom missing. Arachno mean two vertex missing or two atom missing. Suppose you start from 6 boron mean Closo will have 6, Nido will have 5, Arachno will have 4. The names come from the fact that Closo mean closed, Nido mean nest, Arachno means spider type. Here is shown simply for boron. The structure is octahedron, but it can be in any structures. So don't confuse with the fact that Closo only with octahedron. Closo can be on any structure. Nido also can be on any structure. So let us learn what are all the possible types. Possible types are Closo, Nido, Arachno, Hypho, Clado, Supercloso, Hypercloso. Here Closo mean n plus 2, Nido mean n plus 4. So it will go until 10. Supercloso mean n plus 0. Hypercloso mean n minus 2. Here you should know the fact that n will be always even. If it is odd, the calculation may be of mistake. So m is always even number. You should memorize this table and structure name. Otherwise you cannot solve the problems. There will be often confusion. Structure versus weight type. The structure can be anything. Tetrahedron, octahedron, trigonal, bipyramidal. That it has Closo Nido and Arachno. So don't confuse. Always read the question and answer. In this example, I given octahedron. By removing boron, you get different weight types. So don't confuse structure versus weight type structure. Then comes the Zintl salts. How you solve the structure of Zintl salts. For that, you should write boron equivalent. Then only it will be easy. Boron normally has 3 electrons. If you write for carbon group mean, write 3 plus 1. That is boron with hydrogen. Suppose you have tin. Here tin S4 2 minus is given. How you solve the structure mean, write boron equivalent. Tin is in carbon group. Valency is 4. So it can be written as 3 plus 1, that is boron plus hydrogen. So Wade's rule is originated from boron. So we will write boron equivalent. So tin can be written as BH. So whole formula become BH 4 times 2 minus simply B4H4 2 minus. In this way you can find for boron group, carbon group, nitrogen group as well as oxygen group. So fact here is you should learn the equivalent, solve the structure. By now you may realize that without memorizing the order of the element, you cannot solve the problems. So I would strongly recommend that memorize the P block elements. P blocks are boron group, carbon group, nitrogen group, oxygen group. Rarely halogen comes. So all you should memorize. You should know which atom in which group. Then only you can write boron equivalent. Otherwise all the knowledge will be wasted. You cannot solve the problems. So in periodic table, at least you memorize P block elements. Then the very important thing, how you find the structure using step-by-step procedure. First you should write boron equivalent, then count the boron, that is N, then count the hydrogen, that is H, then charge is there, that is C, then find the excess of hydrogen, that will be M, equals H minus C minus N, which gives N plus M architecture. Here if you find n plus m, n plus 2 mean Closo, 4 mean Nido, 6 mean Arachno, 8 mean Hypho, 10 mean Clado, 0 mean Super Closo, minus 2 mean Hyper Closo. Mostly boron equivalent come from carbon, nitrogen and oxygen. Carbon group mean BH, nitrogen group mean BH2, oxygen group mean BH3. Here I give an example sp4 2 minus. Sb is antimony which is in nitrogen group. Equivalent will be BH2. So Sb4 2 minus become BH2 4 times 2 minus. Simply B4H8 2 minus. Here borons are 4. So N equals 4. Hydrogens are 8. So H equals 8. The charge is minus 2. So C is minus 2. So excess of hydrogen will be H minus C minus N. So M equals 8 minus of minus 2 minus 4. It will give M equals 6. M equals 6 mean N plus 6 system which is Arachno. So the structure of sp4 2 minus is Arachno. So you should know order of identification. Then only you can solve the structure simple way. Then sometime 2 or more metal containing salts will come. Here I given SN2 Bi2 2 minus. Don't get confused. Write the boron equivalent. Solve with the Wade's rule. Here tin is given. Bismuth is given. Tin is in carbon group, so BH. Bismuth is in nitrogen group, so BH2. So the equivalent will be BH2 times BH2 2 times 2 minus. If you simplify, you have B4H6 2 minus. You can apply the weights rule. Then the important one, you may commit a mistake, but the mistake can be easily identified through the value of m. M never be a odd number. If it is odd, it is a mistake. Here I given simple example P4. Mistakenly I given the calculation. Boranes has 4 mean. It will give m equals 3. M equals 3 is odd number. It cannot be. In that way you can identify the problem. You can solve the examples. Then we are going to see 20 solved example. Why so many means problems are best way to learn. It will give different perspective. Here the first example. Predict the structure of SN9 4 minus using weights rule. Here metal cluster is given, that is Zintl salts. We should write boron equivalent to find the structure. Tin is in carbon group, so equivalent will be BH. So the SN9 4 minus, if you substitute boron equivalent, it become BH9 4 minus, that is B9H9 4 minus. It becomes simple boron. So we apply the weights rule. Here borons are 9, so N equals 9. Hydrogens are 9, so H equals 9. Charge is minus 4, so C is minus 4. If you find excess of hydrogen, that is M equals H minus C minus N. H is 9, C is minus 4, N is 9. Then M will be 4. M is 4 mean it is N plus 4 system. N plus 4 mean Nido structure. So according to the weights rule, the Zintl salt SN9 4 minus has the Nido structure. Then the next example, Tl2 Te2 2 minus. Two metals are there, tellurium and thallium. You should find the structure using weights rule. Here Tl2 Te2 2 minus is given. Two heteroatom, thallium and tellurium. Zintl salt formed from two metal. Thallium is in boron group. Tellurium is in oxygen group. So thallium equivalent will be boron. Tellurium equivalent will be BH3. So if you substitute, the formula becomes B2 BH3 twice 2 minus. If you simplify, it becomes B4H6 2 minus. The compound becomes simple boron. So we apply the weights rule here. Counting the boron will be the first step. There are 4 borons, so N equals 4. Hydrogens are 6, so H equals 6. Charge is minus 2, so C is minus 2. So the excess of hydrogen will be M equals H minus C minus N, that is 6 minus of minus 2 minus 4, which gives 4. So it becomes N plus 4 system. N plus 4 mean Nido structure. So according to the weights rule, Zintl salt Tl2 Te2 2 minus has the Nido structure. Then the next example, S4 2 plus, that is sulfur dication. You should find the structure using weights rule. Here S4 2 plus is given. It is a Zintl salt. So we should write boron equivalent first. Sulfur is in oxygen group. So S equals BH3. If you substitute it, the structure becomes BH3 4 times 2 plus. If you rewrite it, you have B4H12 2 plus. The compound becomes simple borane. So we apply the weights rule. First step will be counting the boron. Borons are 4, so N equals 4. Hydrogens are 12, so H equals 12. Charge is plus 2, so C is plus 2. The excess of hydrogen is the important step here. To find the excess of hydrogen, that is M, which equals H minus C minus N, you apply the values. So 12 minus 2 minus 4. gives 6. M is 6 mean N plus 6 system. N plus 6 mean Arachno structure. So according to the weights rule, the Zintl salt S4 2 plus has the Arachno structure. Then the next example, InBi3 2 minus is given indium bismuth Zintl salt. You should find the structure using weights rule. Here dimetal is given. We will go by the basics. It is a Zintl salt. We will find boron equivalent. Bismuth is in nitrogen group, so BH2. Indium is in the boron group, so boron itself. If you apply the equivalent, the structure become BH2 thrice 2 minus. If you rewrite it, it become B4H6 2 minus. The compound becomes simple borane. You should apply the weights rule to find the structure. First step will be counting the boron. There are 4 borons, so N equals 4. There are 6 hydrogen, so H equals 6. Charge is minus 2, so C is minus 2. You have to find excess of hydrogen, which is M, that is equal to H minus C minus N, that is 6 minus of minus 2 minus 4, which gives M equals 4. M equals 4 mean N plus 4 system. N plus 4 system has Nido structure. So according to the weights rule, InBi3 2 minus, the Zintl salt, has the Nido structure. Then the next question, BB5 2 minus, that is lead metal cluster dianion. You should find structure of the compound using weights rule. Here BB5 2 minus is given. It is a metal salt, typically a Zintl salt. Lead is in carbon group, so the equivalent will be BH. If you substitute BH for BB, the formula becomes BH5 2 minus. If you rewrite it, it becomes B5H5 2 minus. It becomes simple boron, so we apply the weights rule. First step will be finding the boron. There are 5 boron. N equals 5. Hydrogens are 5. So H equals 5. Charge is minus 2. So C is minus 2. Then we will find excess of hydrogen, that is H minus C minus N. If you substitute the values, 5 minus of minus 2 minus 5, it becomes M equals 2. M equals 2 mean it is N plus 2 system. N plus 2 system is Closo structure. So according to the weights rule, the Zintl salt BB5 2 minus has Closo structure. Then the next example, Bi5 3 plus bismuth 5 times trication. You should find the structure using weights rule. Here Bi5 3 plus metal cluster, typical Zintl salt. We should write boron equivalent. Bismuth is in nitrogen group, so the equivalent will be BH2. So if you substitute BH2 for bismuth, the formula become BH2 5 times 3 plus. If you rewrite it, you have B5H10 3 plus. The compound becomes simple boranes. Then we apply the weights rule. First step will be counting the boron, that is N equals 5. Then counting the hydrogen, H equals 10. Charge is plus 3. So C equals 3. You have to find excess of hydrogen, that is M equals H minus C minus N, that is 10 minus 3 minus 5 gives 2. M equals 2 mean it is N plus 2 system, technically Closo structure. So according to the weights rule, the Zintl salt Bi5 3 plus has Closo structure. Then the next example, P4, that is phosphorus molecule You should find the structure using Wade's rule. Clearly P4 is indel salt. You have to find the boron equivalent. Phosphorus in nitrogen group. So equivalent will be BH2. So boron equivalent P4 mean BH2 4 times, that is B4H8. The compound becomes simple borane. We can find the excess of hydrogen easily. First step will be counting the boron. Number of borons are 4, so N equals 4. Number of hydrogens are 8, so H equals 8. Charge is not there, so C is 0. Excess of hydrogen will be M equals H minus C minus N, which gives 8 minus 0 minus 4, 4. M equals 4 mean it is N plus 4 system. If you look at the table, N plus 4 mean Nido. So, according to the Wade's rule, Zintl salt P4 has Nido structure. Then the next example. Here you have Ge9 2 minus germanium dianion. You should find the structure using Wade's rule. The compound is Ge9 2 minus germanium cluster. So it is a Zintl salt. So we should find germanium equivalent. Germanium is in the carbon group. So BH will be the equivalent. Instead of germanium, if you substitute the BH, the formula becomes BH9 times 2 minus. If you rewrite it, it becomes B9H9 2 minus. So the compound becomes simple boron. For the Wade's rule, you have to find the excess of hydrogen. First step will be counting the boron. There are 9 borons, so N equals 9. Hydrogens are 9, so H equals 9. Charge is minus 2, so C is minus 2. Excess of hydrogen will be M, which equals H minus C minus N. If you substitute it, 9 minus minus 2 minus 9. So excess of hydrogen will be M equals 2 mean it is N plus 2 system. If you look at the table, N plus 2 mean Closo. So according to the Wade's rule, the Zintl salt Ge9 2 minus has the Closo structure. Then the next example, here you have Sb4 2 minus, that is antimony dianion. You should find the structure using Wade's rule. Here Sb metal cluster is given, clearly a Zintl salt. So we should find boron equivalent. Antimony is in nitrogen group. The equivalent of boron will be BH2. So if you substitute BH2 for Sb, the formula becomes BH2 4 times 2 minus. If you rewrite it, it becomes B4H8 2 minus. The compound becomes simple borane. So we apply the Wade's rule. First step will be counting the boron. There are 4 borons, so N equals 4. 8 hydrogen, so H equals 8. Charge is minus 2, so C is minus 2. Excess of hydrogen will be M equals H minus C minus N. If you substitute the values, 8 minus minus 2 minus 4, which gives M equals 6. M equals 6 mean it is N plus 6 system. If you look at the table, N plus 6 has Arachno structure. According to the Wade's rule, the Zintl salt Sp4 2 minus has Arachno structure. Then the next example, here Sn5 2 minus is given tin dianion. You should find the structure using Wade's rule. Here tin metal cluster is given, clearly a Zintl salt. You should find boron equivalent. Tin is in carbon group. Equivalent will be BH. So if you substitute BH for tin, the formula becomes BH 5 times 2 minus. If you rewrite it, B5H5 2 minus. The compound becomes simple borane. So we count the number of boron. Number of borons are 5. So N equals 5. Number of hydrogens are 5, so H equals 5. Charge is minus 2, so C is minus 2. Excess of hydrogen will be M, which equals H minus C minus N. If you substitute the values 5 minus minus 2 minus 5, so excess of hydrogen will be M equals 2. M equals 2 mean it is N plus 2 system. If you look at the table, it has Closo structure. So according to the weights rule, the Zintl salt SN5 2 minus has Closo structure. Then the next example, here you have germanium 10 times 2 minus dianion. You should find the structure using weights rule. The given compound is Ge10 2 minus, technically a Zintl salt. So we should find boron equivalent. Germanium is in the carbon group, so equivalent will be BH. If you substitute the BH in germanium, the formula become BH 10 times 2 minus. If you rewrite it, it will be B10 H10 2 minus. The compound becomes simple borane, so we apply the weights rule. First step will be counting the boron. Number of borons are 10, so N equals 10. Number of hydrogens are 10, so H equals 10. Charge is minus 2, so C is minus 2. Excess of hydrogen will be M equals H minus C minus N, which gives M equals 10 minus of minus 2 10 times. Excess of hydrogen M equals 10 minus minus 2 minus 10, which gives M equals 2. M equals 2 mean N plus 2 system. If you look at the table, N plus 2 mean Closo structure. So according to the weights rule, the Zintl salt Ge10 2 minus has the Closo structure. Then the next example, here you have SN4 2 minus tin 4 times dianion. You should find the structure using weights rule. Here tin metal cluster is given, clearly a Zintl salt. We should find boron equivalent. Tin is in carbon group, so equivalent will be BH. So instead of tin, if you write BH, the formula becomes BH4 2 minus. If you rewrite it, it becomes B4H4 2 minus. The compound becomes simple boron, so we go by normal weights rule. First step will be counting the boron. Number of borons are 4, so N equals 4. Number of hydrogens are 4, so H equals 4. Charge is minus 2, so C is minus 2. Excess of hydrogen formula will be M equals H minus C minus N, which gives 4 minus minus 2 minus 4. So excess of hydrogen will be M equals 2. M equals 2 mean it is N plus 4 system. If you look at the table, it is Closo structure. So according to the weights rule, the Zintl salt SN4 2 minus has Closo structure. Then the next example, here you have Bb2 Sb2 2 minus dimetal system, lead and antimony. Anion is in the system. You should find the structure using weights rule. The compound is interesting because cluster formed by two metals Bb2 Sp2, lead and antimony. So we should write boron equivalent. Lead is in carbon group, antimony is in nitrogen group. So lead equals BH, antimony equals BH2. So if you substitute lead and antimony equivalent, the formula become BH 2 times BH2 2 times 2 minus. If you redraw, you have B4H6 2 minus. The compound becomes simple boranes. You can apply the weights rule. First step will be counting the boron. Number of borons are 4, so N equals 4. hydrogens are 6, so H equals 6. Charges are minus 2, so C equals minus 2. The excess of hydrogen will be M equals 4. M equals 4 mean it is N plus 4 system. If you look at the table, N plus 4 mean Nido structure. So according to the weights rule, the Zintl salt Pp2 Sb2 whole 2 minus has Nido structure. Then the next example, Sn2 Pa2 2 minus. You should find the structure using weights rule. Here Sn2 Pa2 2 minus dimetal cluster, clearly a Zintl salt. We should find boron equivalents to solve the structure. Tin is in carbon group, equivalent will be BH. Bismuth will be in nitrogen group, equivalent will be BH2. If you substitute equivalents for tin and bismuth, the formula becomes BH2, BH2 twice, 2 minus. If you rewrite it, it becomes B4H6 2 minus. So the compound becomes simple boranes. We can apply the weights rule now. First step will be counting the boron. Number of borons are 4, so N equals 4. Number of hydrogens are 6, so H equals 6. Charges are minus 2, so C is minus 2. Excess of hydrogen will be H minus C minus N. If you substitute the values, it becomes 6 minus minus 2 minus 4. If you solve it, you get M equals 4. M equals 4 mean it is N plus 4 system. If you look at the table, N plus 4 mean Nido structure. So according to the weights rule, the Zintl salt Sn2 Bi2 2 minus has Nido structure. Then the next example, here you have As7 3 minus arsenic 7 times trianion. You should find the structure using weights rule. The given compound is As7 3 minus, clearly a Zintl salt. So we should find boron equivalent. Arsenic is in the nitrogen group, so the equivalent will be BH2. So if you substitute BH2 for arsenic, the formula becomes BH2 7 times 3 minus. If you rewrite it, you have B7H14 3 minus. The compound becomes simple borane. We can apply the weights rule here. First step will be counting the boron. There are 7 borons, so N equals 7. Number of hydrogens are 14, so H equals 14. Charge is minus 3, so C is minus 3. Excess of hydrogen finding will be the crucial step here. To find the structure, you should find excess of hydrogen, that is M equals H minus C minus N. If you substitute the values, 14 minus of minus 3 minus 7. If you solve it, you get M equals 10. M equals 10 mean it is N plus 10 system. If you look at the table, N plus 10 mean clado structure. It is kind of unusual, but it has clado structure. So according to the weights rule, the Zintl salt As7 3 minus has clado structure. Then the next example, here you have Te4 2 plus tellurium dication. You should find the structure using weights rule. The given compound is Te4 2 plus, clearly a Zintl salt. So we should find boron equivalent. Tellurium is in the oxygen group. Boron equivalent will be BH3. If you substitute BH3 for tellurium, the formula becomes BH3 4 times 2 plus. If you rewrite it, the formula becomes B4H12 2 plus. The compound becomes simple boron. So we can apply the weights rule. First step will be counting the boron. There are 4 boron, so N equals 4. Hydrogens are 12, so H equals 12. Charge is plus 2, so C is plus 2. Excess of hydrogen formula will be M equals H minus C minus N. If you substitute the values 12 minus plus 2 minus 4. If you solve it, you have M equals 6. M equals 6 means it is N plus 6 system. If you look at the table, N plus 6 mean Arachno structure. So according to the weights rule, the Zintl salt Te4 2 plus has Arachno structure. Then the next example, here SN5 Sb3 3 minus is given. Tin and antimony metal cluster trianion system. You should find the structure using weights rule. The given compound is a metal cluster formed by two metal, tin and antimony, clearly a Zintl salts. If you write boron equivalent, tin will be BH, antimony will be BH2. If you write boron equivalent in the system, the formula become BH5, BH2 3 times 3 minus. If you rewrite it, you have B8, H11 3 minus. So the compound becomes simple borane. You can apply the weights rule here. First step will be counting the boron. Number of borons are 8, so N equals 8. Number of hydrogens are 11, so H is 11. Charge is minus 3, so C is minus 3. Excess of hydrogen formula will be M equals H minus C minus N, which gives 11 minus minus 3 minus 8. So excess of hydrogen will be M equals 6. M equals 6 mean N plus 6 system. If you look at the table, N plus 6 mean Arachno structure. So according to the weights rule, the Zintl salt SN5 Sb3 3 minus has Arachno structure. Then the next question, here Sb7 3 minus is given, antimony 7 times trianion. You should find the structure using weights rule. Here the metal cluster is given. The metal cluster formed by antimony, technically a Zintl salt. So we can apply the weights rule through boron equivalent. The boron equivalent of antimony will be BH2 because it is in the nitrogen group. So if you substitute BH2 for Sb, the formula becomes BH2 7 times 3 minus. If you rewrite it, it will be B7H14 3 minus. So the compound becomes simple borane. You can find the structure using weights rule. First step will be counting the boron. There are 7 borons, so N equals 7. Number of hydrogens are 14, so H equals 14. Charge is minus 2, so C is minus 2. Excess of hydrogen will be M equals H minus C minus N, that is 14 minus of minus 3 minus 7. If you solve it, you have M equals 10. M equals 10 mean N plus 10 system. If you look at the table, N plus 10 mean clado structure. So according to the weights rule, the Zintl salt Sb7 3 minus has clado structure. Then the next example, here you have Bi4 2 minus, bismuth 4 times dianion. You should find the structure using weights rule. Here bismuth metal salt is given. It is a cluster, clearly a Zintl salt. Bismuth is in the nitrogen group, so the equivalent will be BH2. If you substitute BH2 for bismuth, the formula become BH2 4 times 2 minus. If you rewrite it, you have B4H8 2 minus. The compound becomes simple boron. So we can apply the weights rule. First step will be counting the boron. There are 4 boron. So N equals 4. Number of hydrogens are 8. So H equals 8. Charges are minus 2. So C is minus 2. Excess of hydrogen will be M equals H minus C minus N, which gives 8 minus minus 2 minus 4. So excess of hydrogen will be M equals 6. So N plus M system mean it is N plus 6 system. If you look at the table, N plus 6 mean Arachno architecture. So according to the weights rule, the Zintl salt Bi4 2 minus has Arachno structure. Then the final example, here you have Te6 2 plus tellurium 6 times dication. You should find the structure using weights rule. The compound is Te6 2 plus tellurium cluster, clearly a Zintl salt. So you should find boron equivalent. Tellurium is in the oxygen group. So boron equivalent will be BH3. If you substitute BH3 for tellurium, the formula becomes BH3 6 times 2 plus. If you rewrite it, you have B6 H18 2 plus. So the compound becomes simple borane. You can apply the weights rule here. First step will be counting the boron. There are 6 boron, so N equals 6. There are 18 hydrogen, so H is 18. Charge is plus 2, so C is plus 2. Excess of hydrogen will be H minus C minus N. If you substitute it, you have 18 minus plus 2 minus 6. Excess of hydrogen will be M equals 10. If you solve it, you have M equals 10. M equals 10 mean it is N plus 10 system. If you look at the table, it has clado structure. So according to the weights rule, the Zintl salt Te6 2 plus has clado structure. We summarize what we learned. First, we should know how to find the structure. To identify the structure, you should find the excess of hydrogen that will give M. The formula of M is H minus C minus N. Once you find the M, you should find N plus M. M will be the even number. N plus 2 mean Closo. N plus 4 mean Nido. N plus 6 mean Arachno. N plus 8 mean Hypho. N plus 10 mean Clado. N plus 0 mean super Closo. N minus 2 mean hyper Closo. In Zintl salt, for the weights rule, you should know the boron equivalent. Boron group equivalent will be B. Carbon group equivalent will be BH. Nitrogen group equivalent will be BH2. Oxygen group equivalent will be BH3. You substitute the values, then you can apply normal weights rule. There are so many examples are possible. Better solve by yourself. Understand the concept better.